Hello, my beautiful AP Computer Science students. Welcome to another lesson in our 9th unit, Inheritance. And this lesson is going to be focused on a special type of occurrence called upcasting and aliasing. So both of these are going to be discussed. They come up when you are working with inherited objects, and we'll talk about exactly what happens with them. We're going to focus on upcasting first for the majority of our lesson, and then at the end of our lesson, we're going to talk about aliasing and exactly what that is. So upcasting. In Java, when an object is declared as one type but created as another type, we call that upcasting. So it basically looks like we're kind of mixing types in an inheritance hierarchy. So you're allowed to do this, and there are reasons where we want to do this that we'll see, but it's basically where it almost seems like you're mixing data types in a way, but those data types have to be in an inherited relationship. So it's kind of a form of polymorphism that means we get to treat an object of some subclass as an object of the superclass, which again, there are specific instances where we might want that, and I will show you an example of when it is useful. But for our first couple of examples here, talking about upcasting and showing you example code, we're just going to really just define it, okay? It helps us with some flexibility in our code, even though at first it seems a little weird, like why would we want to do this? It does help us with some flexibility in our code, and it helps us achieve some instances that we weren't able to achieve before. So here's an example. So I'm going to use our person, student, and AP student classes that we have been using throughout our unit, Inheritance. So if you have that code, that sheet, I would get it out now just so we can kind of refer to it. But here's an example of what an upcasting line of code looks like. There it is. Right? Person Julia equals new student. Okay. So there's a couple things happening here. First, when you look at that, if that's your first time seeing upcasting, you notice that you're mixing types, right? Julia is declared as a person. So we call Julia's declared type a person. Julia is our reference. So we're going to be talking about, when we talk about a reference variable, Julia is the reference variable. And her declared type is a person. So the declared type of your reference variable decides which method to match at compile time. So when you go to, if you were to run a method using Julia, Julia dot say something, or Julia dot get age. Okay, if you were to use a method with Julia, that method has to be in the person class in order for it to compile. It has to be in the person class, or it can be in any classes above person, which there's not in our examples. But that declared type says which method you're going to match at compile time. Okay. When it's compiled, only methods present in person will be able to use on Julia. Okay. Because Julia is declared as a person. Now, Julia's actual type is a student. Julia is created as a student. Now, Julia is created as a student because we use that new operator and we use the student default constructor, right? So the actual type of the reference is what is implemented at runtime. Okay? So when this is run, the methods that are present in student will actually be checked first, and those will be run before it moves up the inheritance hierarchy. Okay? So that's kind of why this is a form of polymorphism. Okay? Because which method needs to be present at compile time versus which method needs to be present at runtime. It just depends on what you're upcasting as. Okay. All right. We're going to see plenty of examples and trace through plenty of examples so that this feels more comfortable for you. Okay, so stick with me here. So the declared type must be higher in the inheritance hierarchy than the actual type. Okay? If not, an error will occur. Okay. So what I mean, remember this is our inheritance hierarchy that we have with person, student, and AP student. Okay. AP student is a student and student is a person. Okay. Those are the relationships we have. And there's only one way to upcast, okay? And that is the declared type must be higher in the inheritance hierarchy than the actual type. So this first line, person Julia equals new student, that we just had, that's legal, okay? Person is higher in the hierarchy than student, okay? So because person is declared and student is created, this is legal, okay? If we look at our next one, person Stephen equals new AP student. Person is higher than AP student, so this is also a legal upcasting assignment. Okay. So you need to be able to determine what statements, what objects being created are going to be legal and which are going to be illegal. Okay. This one here, student Leroy equals new person. Okay. Student is lower in the hierarchy than person. Okay. So this is an example of an illegal upcasting. Same thing here, AP student Emmy equals new student. Because AP student is lower than student, this is also illegal. Okay, but in this one, student 1 equals new AP student. Student is higher than AP student, so this is legal. Okay. Okay. This is why a lot of the times I suggest you write out an inheritance hierarchy like this when you have multiple classes interacting with each other in an inheritance hierarchy. Write out the hierarchy, especially if you have lines of code like this where you have to determine what's legal and what's illegal, and it can help you visually pick out which ones are going to be okay and which ones are not going to be okay, especially as you're learning it right now, because it probably feels a little bit weird. Okay. So you have illegal and legal assignments in upcasting. Now constructors. What happens with constructors? Because we just saw, Juan is created as an AP student. He uses the AP student constructor. What does that exactly look like? Well, upcasting, the weird stuff kind of happens more with methods, and that's just due to the polymorphic behavior that it has. It doesn't necessarily happen the same with the constructors. Constructors still kind of behave like they've always behaved for us. Even when we are upcasting, you will see constructors used in conjunction with upcasting, but again, nothing really polymorphic or weird happens with constructors. And that's because constructors aren't inherited, remember, okay? So here's an example. We're going to go through first two examples of just regular object creating, and then we're going to see examples of this upcasting being used. Okay, so there's a lot on the screen right now. Let's kind of orientate ourselves as to what's happening here. I have a superclass over here. It has an instance variable. It has a default constructor, and it has a parameter constructor. Okay. Then I have subclass is going to extend superclass. Okay. It has one instance variable. It also has a default constructor, and it also has a parameter constructor. Okay. I can see that I have some calls to the super default and the super parameter constructor in here. Okay. And that's good. It's on the call to the supers constructor happens on the first line, which is perfect. That's where it needs to be. Okay. So let's see what happens with these constructors. So in this example, I have subclass thing equals new subclass. Okay. So no upcasting. Subclass equals new subclass, what we've always been doing, right? So subclass, I go to the subclasses constructor, the default constructor. The first line is the supers default constructor, so I go over here and I run the supers default constructor. Okay. Now remember, the keyword here is super. Okay, so it's not that these have to match in words, right? We know that the default constructor has to match the class name, okay? But super is the keyword. It automatically goes one above it in the inheritance hierarchy and runs the default constructor, and it knows the default constructor because of that parameter list, Okay, so just remember. So this default constructor runs. So I print off super default, num equals 10. And then I come back here and I print off sub default and age is 5. Okay. Wham, bam. Thank you, ma'am. This next one. In this example, I kind of skipped over but it says subclass thing equals new subclass, and I use the parameter constructor. So I go to the parameter constructor of my subclass that accepts 2 integers. I have my first line, I have a call to the super parameter constructor. So again, it goes super is the key word, it goes 1 above it, and it looks for that single parameter constructor. It's going to find it and print off super parameter. Okay. So num, if you want to trace this kind of behind the scenes, 3 was the first number I passed here. 3 is what gets passed to my super, which becomes amount. And then 3 ends up becoming the value of num, which is my instance variable. Okay. So 3 kind of got passed all around until eventually it winds up being the value of num. Okay, but super parameter gets printed to the console, num becomes 3, and then I come back here, I print off sub parameter, and then age gets amount, so it gets the 8. Okay. So I'm just recording what's printed to the console here, super parameter, then sub parameter, but behind the scenes, values are getting assigned to these instance variables too. Okay. All right, let's see our first example of upcasting. So recognize this as an upcast. I have superclass thing equals new subclass. Okay, that is legal. Okay, because I have super and then sub. Okay, so it has to flow super and then sub. So it's legal. And look at what's the constructor being used. Okay, subclass is constructor. So we start at the subclass constructor. I run the super parameter in my superclass. Super default gets printed, and then sub default gets printed. Okay. Num becomes 10, age becomes 5. We're done. Okay. Which is exactly how the other pieces of code we just did behaved. So the fact that I upcasted here really had no impact on the execution of constructors. Okay. So that's kind of what I want you to take away from this piece here and the next couple of examples is the upcasting with constructors. It doesn't really do much. It's really, upcasting really just affects methods and that polymorphism with methods. Okay. So here's another example. Superclass thing equals new subclass 2, 3. So again, it's legal. Okay. I have my parent class here, and I got my child class over here. That's good. Okay. Legal, totally fine. The parameter constructor in my subclass is what gets executed. So 2 is number, 3 is amount. I pass 2 to my super. Here I run super parameter. Num is going to be a 2. I come back here, I print off sub parameter, and 3 gets to be age. Okay. All right. So those are the examples of the constructors being used, and again, just kind of in the predictable way that we've always been using them. Okay, but let's see exactly how upcasting works with methods. Okay, so remember, a reference variable is only able to use methods that are defined in the declared type. Okay, so that first class is the declared type. If you try to use any method that is not in the declared types class, you will get a compiler error. Now I say it has to be the declared types class, but it can also be a method that's above the declared type in the inheritance hierarchy. Okay, and we'll see examples so that it sticks out in your head. But the compiler will look in the declared types class for that method, and it'll follow the inheritance hierarchy up to see if it can find the method above it. Okay, but it starts in that declared type. So if your method is below in the inheritance hierarchy and the compiler doesn't find it in the declared type or above, it's going to throw a compiler error. Okay. When actual running, right, a reference variable will check its actual typed class first. So what it was created as. So whatever it's created as, then it looks in that class first, and it'll move up the inheritance hierarchy until it finds it. Okay. We'll see an example of this, of course, but you can also do what's called a downcast, right? By explicitly casting the reference that allows it to compile and run the methods that are in the actual type. Okay. And again, you'll see examples of all of this, and you'll walk away feeling much better once you see examples of all of this. Here we go. So again, I'm using person, student, and AP student classes. Have that sheet out, but I'll try to remind you of what's written in each of those classes as we go through. Okay. So here's what I have. Person John equals new student. Okay. First, this is a legal upcast. Person John equals new student. Okay. I got my parent as declared and my child as created. Perfect. So that's legal. Next, John is going to try to say something. Okay. Now, the say something method is in the person, student, and AP student classes. Okay. Each one of those had a say something method. Okay. So say something, because it is in the person class, will compile. Okay. So say something, that method is in person. So it compiles. Perfect. And then when you go to run it, it'll actually check the student class first for the say something method. Okay. So this is the big thing with upcasting right here. Okay. Say something. It has to be in person in order to compile, and it is. Perfect. Once it compiles, then because John is created as a student, the program running will say, okay, let's go to student and let's check inside the student class for the say something method. It'll find that say something method. He says, I am a student, and it'll print it off. Okay. If it didn't find say something in student, then it would move up then hierarchy to person and check in there and run that one. But because it finds it in student first, it runs the say something method in student. And it says, I am a student. Okay. If I could sum up upcasting, it would be with that example right there. Just that, right? That is the entire thing with upcasting demonstrated right there. Okay. Here's our next one. Again, legal person John equals new student. Okay. It's a legal upcast. We're good. John.pass exams. Okay. What is pass exams? Pass exams is present in the student class. It is not present in person. Pass exams is only a method in the student class. There is no pass exams in person. So what that means is because pass exams is not a method in person, this will not compile. Okay. You will get a compiler error. Or if you're working on Replit, it'll give you an error message before you can compile it, but it'll say it's not legal because pass exams is not in person. This is illegal code. Now, if we wanted John to pass exams, because John, he's created as a student, which means he has an age and he has a grade level. Okay. So John, he can pass exams. Pass exams increased his grade level. He's able to do that, but how can we run it? Okay. In this case, this is where downcasting comes in. Okay. The correct way to downcast is instead of doing John.pass exams, we have this. We cast, kind of like how we would cast a double into an int, right? We would do the same thing here. We put in parentheses student right before our reference variable of John. And what this does is it is a temporary cast, right? It doesn't change John, okay? But it basically temporarily, what I always kind of like want you to picture, I guess, is makes it like this. A downcast kind of makes John behave the way that we've always had objects behave, right? So that he can run anything in student or above, okay? Which includes the pass exams method. Now again, this, when you downcast, it's temporary just for that line. Excuse me, I'm talking too much. It's just temporarily for that line. He's not permanently changed to a student. He is still declared as a person. Okay, just temporarily. It allows us to run the pass exams method. All right, cold coffee always settles the throat. Okay, let's see some more examples. Okay, legal up. I always check this first. Is this legal? Yes. Person John equals new student. Awesome. So now we got a print line statement. Student John dot get grade. Okay. Get grade is a method in student. It is not a method in person. Okay. But because he's being downcasted to a student, this allows John to behave like a student, meaning he can run any methods that are present in student. So even though it's not in person, he can run the get grade because he was downcasted for this line of code. And that's basically what that says here. Explicitly casted as a student object, the compiler will allow it. And again, this is temporary. Okay, so if later in your code you did John.getGrade and you tried running it later on, you would get a compiler error. Okay, because getGrade is not in person, so you just can't run that line of code. Okay, that explicit cast allows you to do that. Okay, and when John's created as a new student, he starts in grade 9. So getGrade, the console will print off a 9. Next example, is this legal? Student Lizzie equals new AP student. That's good. Okay, that is good. Let's see here. So new AP student with 2 parameters. I think AP student was supposed to have 3 parameters, unless the default age might be 0. I don't know. I'll have to look back at that code. But it's legal. It's a legal upcasting. Okay, so student equals new AP student. Perfect. Lizzie dot say something. Okay, say something is in both student and AP student. So Lizzie it's correct. You can run that code because say something is in the student class. And then when we actually go to run it, it'll run the say something method in AP student. Okay. This next line, Lizzie.getGrade, getGrade is a method in student. Okay. So that's good. It's a method in student, so it compiles. So everything compiles fine, right? When you're using Lizzie here in your code and you're using any method, you always have to ask yourself, is that method in the declared type? Yes, say something is in student. Yes, getGrade is in student. Okay. As long as those are true, then you compile fine. And then what happens at runtime is a whole other thing, right? So it compiles. At runtime, the program looks in AP student class for the methods first. Okay? It looks in the AP student class for the methods. So Lizzie.say something, it looks in AP student and it will find it. It says I am an AP student. And it looks for getGrade in AP student. But there's not a getGrade method in AP student. The getGrade method is above it. So because of inheritance, if it can't find it in AP student, it goes one above because it inherits from student, and it'll find the method there and run it. We did have a 2-parameter constructor in AP student. The default age was, I think, 0, and then grade is 11, and AP exam score is 4. Good stuff happening. I think these are the last 2 examples in this section here. So person Sally equals new AP student. Okay. That's legal. That's okay. Okay, because we got person up an AP student down here. So because declared is higher in the hierarchy than created, that's illegal upcasting. Okay, so this is her age, her grade, and her exam score, right, for that default constructor. So what you have to decide, I use Sally twice here. I do Sally.HaveBirthday and Sally.GetAge. So you first have to ask, does this compile? HaveBirthday is in the person class, so that's okay. GetAge is in the person class, so that's okay. So this compiles fine. Both of those are in the person class, so it compiles A-okay. All right. Then at runtime, these methods, Sally.HaveBirthday and Sally.GetAge, are run through inheritance, meaning the program will check AP student class for these two methods first, and it won't find it, so it'll go up to the person class, or it'll go up to the student class. It'll check for those two methods in the student class, and it won't find it, so then it'll go up to person, and then it'll find those there. Okay. So Sally has a birthday, so her age increases by 1, and then when we get age, it turns out to be 18. Okay. All right, and then this one, person Sally equals new AP student, so same thing. Now I have Sally.study for exams and Sally.get AP exam score. Okay. Study for exams and get AP exam score, both of those are actually not in the person class, right? Those are two methods in AP student, but they are not in the person. And this is always what gets students, is they say, but she is an AP student, so she should be able to run those methods. And I understand that's what it seems like, but with upcasting, it has to be present in this class in order for it to compile. Okay. So because they are not in the person, this is illegal code and it will not work. Okay. So when you run into these problems, check first to make sure that this is legal, okay, that you have a legal upcast. Next, if you use this reference anywhere, make sure that these 2 or 3 or whatever methods, make sure that they are in that declared type. Okay, that's step 2. If they're not in the declared type, it won't compile. Okay, and then by the time you reach the third step, you've determined everything is legal, and you actually run the code, and you run the code like Sally is an AP student. Oh, I have one last example. Fixing that. This is explicitly casting Sally so that you're able to run those methods, right? So Sally is a person, but here's our explicit explicit downcast for Sally so that she is able to behave and run those methods like an AP student. So now it will run. Right? She'll study for exams, which means that her AP score increases by 1, and then when you print off her new AP score, it's going to be a 3. And that's the gist of upcasting. Right? More examples, because I truly don't think we can do enough of these examples to help us out here. So this is going to be just a simplified super and subclass, okay? Just to kind of work with this upcasting some more, and also see how it works with some method chaining here. So notice I have my superclass, and I have a method called A and a method called B. Then I have a subclass that extends the super. It has a method A and a method C. So let's see what happens, because I see here I have a super.a. Here I just have a method called A. Okay. So we have a couple methods getting thrown around. Oop, as I throw my pens. So we're throwing everything. Let's see what happens with these lines of code and how it behaves. So I see I have subclass thing equals new subclass. No upcasting. Just a regular old object instantiation here. Subclass thing equals new subclass. Then I have thing.b. Okay, so B. Thing is a subclass. So I go to subclass and I look for the B method and I don't find it. But because I'm working with inheritance, I go to superclass and I look for my B method and I find it. Okay? I find it right there. That is my B method that I'm going to run through inheritance. Now in that B method, I have A, empty parameter set. So I'm calling the method A. Here's the thing. Which A method do I run? Do you know? We've seen this before, so hopefully you kind of know. But we run B. We started in subclass. We go to the super to find B. We found it. And now we have to run A. So who runs A? Well, this makes the method call using thing. Okay? So whenever we make a reference call using an object, if we make another reference call in the reference call, we still use thing. Okay? Now because we use thing is run as a subclass, okay? Which means that we go back to the subclass and we run that A method. Okay? It's a good time. B, we found B in the superclass, but because the call to A still uses the calling references class, we go back to the subclass and run that A method. So this prints off sub A. It's a good time. It's a good time. It always comes back to what your reference, when you're running the program, what is your reference created as? Okay. Always comes back to that. That's always your starting point in your inheritance hierarchy. When you're running a program, what is your reference created as? Okay. So I come over here. Subclass thing equals new subclass. Again, no upcasting. Thing.c. Okay. So I go into my subclass and I find C. So I'm going to run it. Now I have a specific call to super.a. Okay. Now I want to say if this wasn't here, if I just had A, because thing is a subclass, I would run this right here. But I do have super.a, which means it's an explicit call to super's A method. So this is the method that runs. Okay. So this will print off super A. Distinction. So that was kind of review a little bit because we didn't really use upcasting in that example. But that's how you trace those method call chains. Okay. Now let's do the same thing but with upcasting. Okay. Upcasting. Superclass thing equals new subclass. Upcasting. It's legal for one. So next I need to see, okay, C. Is C in my superclass? Because that was step 2, right? Step 1 was making sure it was a legal upcast, and it is. Step 2, is C in my super? Okay. Is C in super? No. C is not in super. So it'll not compile. This is illegal code. Did I get you? Did I trick you? Okay. Check for the legal upcast. Check if that method is in the declared type. And if both of those are true, then run your code. Okay. Super equals new sub. That's legal. Second step. Is A in my super? It is. Woo! A is in super, so it compiles. Step 3, rerun it. Okay? We run by checking the subclass for an A method first. Okay? Compiles since A is in super. I'm getting ahead of myself. I made all these fancy slides with my arrows and then I just talk above myself. We run the A in the subclass, okay, when we're running our program in our step 3. So this will print off sub A. Yes, yes, we love it. 2 more examples. Okay. Superclass equals new subclass. Perfect, that is legal. Next, I see a downcast here. Okay, so this was before. If we didn't have subclass there, thing.c, we just said we can't run. Okay? But now we have an explicit downcast, okay? An explicit cast. So subclass thing.c, that says, okay, it's legal because thing is created as a subclass, so you're allowed to downcast it to a subclass, okay? So that says, okay, compiler, hey, compiler, if C is in subclass, you can compile fine. And it is. C is in subclass, so we compile just fine. And then it's able to run it. And it runs it, explicit call to the supers A method, so it'll print off super A. Okay. Here, superclass equals new superclass, so there's no upcasting. But here I say subclass thing.c. Okay. Is that legal? Nope. Because I always know this question comes up. You're created as a superclass. If you try to explicitly cast anything under your super, won't work. Illegal. Okay? This does not work. Illegal code. And it's illegal because you're created as a super and you can't explicitly cast as anything less than your what you create as. Okay? You can only explicitly cast as the thing itself that you're created as. Created as a sub, explicitly cast as a sub. Right? Created as a super, can't explicitly cast as anything other than super. I know we're watching this with a smile on our face, and I'm happy about that. Okay, Mrs. Goldschmidt, why do we need to know this? Okay, here's an example. We finally reached the point where I'm like, why is this useful? Okay, you'll see on the AP exam, this is most often used with array list, okay, or arrays, array list. Upcasting is useful when you want to treat objects of a subclass as objects of their super, okay, which enables you to, you'll see, we'll have some more generic code, and we can do kind of generic code things with our data, okay. Again, very, very typical with lists and array lists is upcasting. Upcasting is very typical with lists and array lists. So here's our example. Again, there's a lot going on the screen, so let's go through this. I have 3 simple classes up here. I have public class farm. And in that method, I have make sound method. And it just prints off noise. Then I have a cow extends farm. Again, make sound. And it's going to say moo. Okay. And then I have public class Angus extends cow, make sound beef. Get it? Because Angus is a type of cow. Okay. So I have farm on top. Cow is a farm. And Angus is a cow. Right? Beautiful. So the following code segment creates an array list to store these farm animals. Okay, so what I call farm is just like kind of a generic animal. Maybe I should have called it animal, but I called it farm. So here's an example using this. So here's my array list creation. Array list farm animals equals new array list farm. So I'm creating a list of farm objects. Okay, this is a list of farm objects. Okay. So what I'm going to do, these 3 lines, create my farm objects. Bucky is a farm object, created as a farm object. Chuck is declared as farm, but created as a cow. And Black is declared as farm, but created as an Angus. All of those are legal upcasts. Okay. Well, farm, Bucky equals new farm isn't an upcast, but Chuck and Black both are legal upcasts. We're good. Okay, and then what I do is I do animals.add Bucky, Chuck, and Black. Okay. And that's legal. Okay. Why is that legal? Because of their declared types. Okay. Bucky, Chuck, and Black were all declared as farm, so they can all get added to our array list. Okay. They can all get added. If I had Angus Black equals new Angus, and I tried adding it to animals, which was a farm, you would get a compiler error. Okay. Even through inheritance. It's only through upcasting we are able to achieve this goal. Okay? So animals now have Bucky, Chuck, and Black. Okay. Now, why would I want to do this? Well, oops. Oh, I got too excited, right? Okay, that comes into play with our next line of code that we're going to write here. Iterate over the list and call the make sound on each object. Okay. Now, I can see already, looking at those three classes, that depending on what type of animal they are, they're all going to make a different noise, right? Farm makes noise. Cow makes moo. Angus makes beef. Okay. But I can iterate generically through my array list. Okay. So I say for each animal in animals. Ooh, excuse me, not animal. Ooh. Sorry, that should say farm. Yikes. See this, I should have just named farm animal. Sorry, that's a mistake. So farm A in animals. Okay, so you have to use, I'm glad I made that mistake because it just allows me to kind of highlight this right here. You have to have the same name as your array list. The same object name. Okay. Remember, array list in Java, you cannot mix data types. Okay. In an array list and in an array, you have to have all the same data type. So in an array list, you have to have all farm objects. Okay. And you do because of upcasting. You have all farm objects. Okay. So then when you make your for each loop, you use that same the same object name, farm A in animals. Animals is your reference for your array list. And then a.makeSound. Okay. So what gets printed off? I guess I got to write it off. Well, the first animal, the first farm in our array list is Bucky. Okay. So Bucky.makeSound is basically what this is doing, right? We just kind of use that letter A as an intermediate variable. But Bucky.makeSound. That's legal because makeSound is in farm. Okay. And then because Bucky was created as a farm, you're going to hear noise. It's going to print off noise. Then we move to the next farm, Chuck. Chuck was created as a cow, declared as farm. So it's legal because makeSound, again, is in farm. But it goes to the cow and says moo. Never thought I'd say that in computer science class in high school. The cow goes moo. And then the next one is Black. Created as an Angus. We can run this because makeSound is in farm. Okay, but it checks the makeSound in Angus first and it'll say beef. There we go. Noise move beef. So there are other instances where this is useful. We won't really run into them too much in this class. Again, this is really where upcasting is useful on the AP exam and the examples that you'll see. Okay, we're going to stop upcasting there. We'll practice it a lot more in class as we continue. But the last section of our notes today is on aliasing, okay? Which I know sounds like a weird word, but it is what it is, aliasing. And I'll pronounce it wrong a couple times, I'm sure. It's just a tongue twister for me. Which reminds me, I should take a sip of coffee. Because this is a long video. So an object is aliased if two or more variables hold references to it. please don't make fun of me if I mispronounce this a couple times. It's a tongue twister for some reason for me. But an object is aliased if two or more variables hold references to it. We've actually seen a little bit of this with strings before. But now we're going to talk about it with objects and inheritance. Okay. So let's say you're going to see an example here in a moment. Both Karen and Ken point to the same location in memory. And any changes made to data using one reference happens to the other. Right? We know, we've seen this before with objects and with strings, actually. We've seen them with both. So student Karen equals new student. There she is. If I say student Ken equals Karen, right, that means, hey, Ken, point to the same thing that Karen is pointing to. Okay? So Ken is declared as a student, and then it just equals Karen. And that creates just a pointing reference. Ken, as a reference variable itself, because he never used the new operator, a new student was never constructed. Okay? There was never a construction in memory of a new student. Remember, the only time we construct a new object is when we use the new operator in conjunction with the constructor. Otherwise, it's just what it is. This was the only construction in memory, new student. So Karen and Ken point to the same student. So if I say Karen.set age, okay, we're going to change 0 to 18. And if I print off Karen.get age, it's going to be 18. If I print off Ken.get age, it's also going to be 18 because they point to the same object. I don't think this is anything too new for you, maybe a review. But now let's talk about what happens when we're mixing data types. I say data types, but mixing reference types in an inherited relationship. Okay. So in general, we try to avoid aliasing because it does have some logic issues. So usually we avoid it in good, just like coding practice, right? But you do need to be able to trace it and understand how it works. You really won't be asked to do it on the AP exam. Again, really do it at all. But it's one of those things, okay, if you want to be a good programmer and really know your stuff, you need to know what it is and be able to trace it. Okay. So when you alias a reference with different declared types, you need to make sure that you follow the inheritance hierarchy. So with Karen and Ken, they were both students. So when you do that, it's kind of as business as usual, right? We don't like aliasing, but that's just what it is. But you can do it legally with mixing types in an inherited relationship. You just have to make sure you follow the inheritance hierarchy. So a reference can be assigned another reference above it in the hierarchy, but it can't be assigned it below. And I always say if that's confusing, just know it works the same way as upcasting assignments, okay? Or upcasting statements, okay? When you want a reference to equal another reference, it has to be done so that the reference on the left is higher in the hierarchy than the reference on the right, okay? So just like we had, and we'll see examples here in a moment, but if we had person Ken equals new person, equals new student, right? That's a correct upcasting. Person Ken equals new student. If I were to do like Ken equals Karen, if Ken was a person, declared as a person, and Karen was declared as a student, this would be legal, okay? If it was the opposite way around, student equals person, that would be illegal, okay? So you just have to really know the difference between legal aliasing and illegal aliasing. But legal aliasing works the same way. It works the same way as upcasting. Okay. So here's my example that I love to use. Person, student, AP student. There's our inheritance hierarchy. Here are three people. Person Peter equals new person. Student Scotty equals new student. And AP student Ashley equals new AP student. Okay, perfect. All regular people. I have 3 examples of correct aliasing and 3 examples of incorrect aliasing. These are just single lines of code. They're not used like in a program together, just separate lines of code here. An example of correct aliasing would be Peter equals Scotty. Okay, Peter equals Scotty. Peter is a person and Scotty is a student. Okay, and this is correct aliasing. Again, because person is higher in the hierarchy than student. Another correct aliasing would be Scotty equals Ashley. Again, Scotty is a student and Ashley is an AP student. Okay, so because student is higher in the hierarchy than AP student, this is legal. And then lastly, this is the last example that we have of these. Person Peter can equal AP Ashley. Correct aliasing. Right. So these are correctly pointing, correctly making your pointers. Correctly making the pointers work in memory. The opposite does not work, right? Scotty cannot equal Peter, okay? Because Scotty is lower in the hierarchy than Peter, you can not do this. Incorrect. Ashley cannot equal Peter, and Ashley cannot equal Scotty. So I should have, whatever. These are all incorrect though. Okay. Left has to be higher in the hierarchy than the right, just like upcasting. Okay. This is our last example. I know this video has gone on for a while. Thank you for sticking with me. This is our last example. We're going to go over aliasing here. So for the following, again, we're using person, student, AP student. We're going to trace through this program and determining what is happening. There's some lines in here that are not going to compile correctly. So we're going to identify them and just proceed like they weren't even there. Okay. Okay. Person Peter equals new person. We love it. This is what happens in memory, right? So if you're a visual person, this is perfect for you. Peter is a new person. My age equals 0. Ashley is an AP student, declared as an AP student, created as an AP student. So here she is. This is the default constructor creation for an AP student. My age is 0, my grade is 9, my AP exam score is 3. Okay. Then I got aliasing. Here it is. Peter equals Ashley. First, is this legal? I have person equals AP student. This is legal. Okay, this is a legal aliasing example here. So what happens in memory? Well, Peter points to the same thing Ashley is pointing to. That's what the assignment is. Okay, right? With any assignment, the left is the variable that gets changed, remember. Okay, so Peter, that reference changes and it says, hey, you're going to point to the same thing Ashley is pointing to. Okay, so basically all of Peter's old information about being a student gets lost. Okay, it is no longer there. We cannot get it back after this line of code executes. Peter and Ashley are pointing to the same thing. Okay, now this is great, but it does bring up some polymorphism issues, okay, and some upcasting issues too, because Peter's a person, Ashley is an AP student, right? This is what they're declared as. This is what their memory boxes are. And then this is an AP student object, right? So remember that their boxes, what they're declared as, are different, but they're pointing to the same AP student object, right? So what we just did here is very similar to like person, if we were to say person Peter equals new AP student. Okay, that's not actually what happened, but just kind of trying to relate it to upcasting a little bit, that's what it looks like. Okay, let's move on. What actually happened? So Ashley.set AP exam score. Ashley is declared as an AP student, and this method is in AP student. So perfect, it's going to change. So it changes from a 3 to a 4. That's good. Peter.study for exams. Now remember, Peter is still declared as a person, Okay, so that polymorphic behavior still applies. We have to check to see if study for exams is in the person class. Okay, is study for exams in person? No, right? Study for exams. Even though Peter is pointing to an AP student object, we can't run any methods in AP student unless they are in person. It will not compile. Peter's a person. Okay. Which is why we have the next line. An explicit cast to make student Peter, to make the compiler run Peter as an AP student for that single line. Okay. For that single line. So now we can change. Study for exams means his AP exam score increases by 1. So it becomes a 5. And you'll see that's okay. That's fine. An explicit cast on that line. Ashley.get AP exam score. Ashley is an AP student. Get AP exam score is in the AP student class. This runs. So it's going to print off a 5 because currently my AP exam score that Ashley is pointing to is a 5. Peter.get AP exam score. Again, Peter's a person. Get AP exam score is not in person. So this is another error. It will not compile because Peter is a person. We have to explicitly cast Peter to be an AP student to get that AP exam score. Okay? And we explicitly cast Peter as an AP student because he is pointing to an AP student object. Okay? We could not explicitly cast Peter to a student because he's not pointing to a student object. He's pointing to an AP student object. So it would print a 5. That would be legal line of code. Okay. So that's the most you'll have to do with aliasing is just be able to trace an example like that to determine what happens, you know, what's printed, what's legal, what's not legal. That's kind of where aliasing ends in this course. And that's where our lesson also ends. Finally, Mrs. Goldschmidt, I know it was a long lesson today, so again, I appreciate you guys sticking with me for the length of this lesson, and I will see you next time.